Welcome again to this session. So now we're going to address the second topic of today, which is the Flux export to SimLab. So actually, this is one of the important new features which was in Flux 2025.0, and this is still being updated and upgraded in the next version. So the things I'm going to show you today, they are in the 25.1 version, but this is in constant progress. So there will be even more progress by the end of the year for this feature. I will show you what we can already do today. And the idea of this feature is actually that you may have already a lot of legacy Flux projects. So I call it legacy in this classic interface of Flux. And so since this version, now we have the project export project to SimLab, which will export for you in INP format, multiple files, including a fixed geometry, because it's actually exporting a mesh from your Flux model. But it will also try to carry as much as possible all the physical definition of the model. So which means any infinite box, symmetry, materials, coils, motion definition, parameters, temperature dependent material. So there's a lot of things that can be taken into account. We can see, especially in 3D, we can consider a lot of stuff. In 2D, for now, it's still quite limited. So we cannot really do a lot of 2D exports which contain everything today. But I will show you some very nice example, because at the end, the goal is you transfer directly this project into this in SimLab, and you can solve it straight away on the SimLab side. So the way it works once you're in SimLab is actually you can import your Flux project, which is now an INP format, through the file import solver input file. There's a specific Flux filter. Or even simpler, you can drag and drop your INP file directly into the SimLab window, and it will ask you to load this project. So in order to show you how it works, I prepared 4 little demos. You can see there's an electrostatic, some transient magnetic, and a transient AC 3 example. So let's start with the first one. So this one is an electrostatic 3D model. So we can see inside the Flux project, we have multiple regions. We have phase region, volume regions. We have some materials. We have some epoxy, some conductor parts. Okay. And so this project is meshed, is ready to be solved. And we can go just to the export project to SimLab, as I was showing in the slide. We give it a name, so it will create a folder with that name. And then we can directly switch to SimLab, where we do file, import, solver input file, and we can go and take that folder file. So let's just find it here. Okay, that Flux SimLab init file. So there's no particular import option, just click OK. And during this import, it will propose you to see if there's any missing parts, any things that are not recognized by SimLab. So you will get this log file. So for example, in this case, I think 1 or 2 things may not have worked well. But then we have all the mesh which is there. We can check all the conditions which are there. So we can see all the loads and constraints that have been copied into the SimLab equivalent. And in this case, this model, it has the material as well, and it's actually ready to be solved. So here I have the solved model, which was solved without modification from the initial model. And we can use now the SimLab post-processing tool in particular, if you need to do any specific 3D post-processing. So this is a static model. Now I have a step skew transient magnetic motor. So this one, we can see it has a periodicity, infinite box, a lot of non-mesh coils, particular mesh, so and a circuit to define the back EMF. So this particular model, we can do exactly the same steps: export project to SimLab. We create a new file, and we can switch to SimLab to import our file. Same again, we go to the right folder. There should be a Flux SimLab init file that we can load. And then after a few seconds, so between, let's say, 10 and 30 seconds, then we get directly the file. And here we see there's just a couple of things on the non-mesh coil creation. But this example from the Flux supervisor, I can export it straight away. And you can see kept all the coils, the non-mesh coils, the periodicity, the mesh, the infinite box. It didn't keep the scenario, so I just need to redefine the scenario. And then after solving, now I'm able to plot and to use the post-processing tools from SimLab. So that means I can plot the curve, of course, of the voltage for the back EMF. And I can do nice animations using the SimLab post-processing. So that's 2 examples. Let's do a third one. This one is a switched reluctance machine, and you can see it has a very complex circuit, including diodes and switches. So this one, same workflow, we try to export it. So actually, in this one, the particularity is that there's a lot of formulas and complex links between the different parts. So actually, this model is not able to be imported fully, but to give you an idea of still what is possible, we can see that we can do the same steps. And then once you were in SimLab, only the missing parts would need to be redefined. So you see there's no missing entities, no missing files. But some variables which were complex formula, they have been reset to 0 for now because there's no compatibility with SimLab. So like the switch command, for example, is not possible. But it was able to get all the circuits and all the coils and all the motion and everything directly as a SimLab model. And finally, last example, it's an AC power transformer. So this one, it has a lot of different manual phase region, volume regions. There's some non-mesh coil for the main coils and also for the distribution bars. We have a lot of components there. And same again, we can export that. And this time it's going to create our transient AC solution in SimLab, containing the whole circuit as well to supply the transformer, as well as all the non-mesh coils that we had and all the particular materials and particular let's say region definition, or boundary condition if you want, directly from the Flux model. So you can see through these examples, we can switch from one to the other in these particular 3D cases. And as I was constantly saying, maybe today there are some limitations, so we cannot do everything yet, okay? So especially now in Flux 25.1, we allow a lot more stuff than in 25.0. And so in particular, I recommend that you have a look at the release notes, which will come with the version, because there's a full list of capabilities and limitations or work in progress things that are not fully supported. So the goal is, please have a look, try it on your model if you want to use SimLab. So that way we can get your feedbacks as well and make it even better in the future for even smoother transition to SimLab. So as I was saying, there's a few next steps on this topic. So the first one is to continue the compatibility for all applications and dimensions. So especially the 2D part, which is not fully covered. So today you can export a 2D model, but it will not have all the circuit association, for example. So you can use it to export a model and then you finish to build it in SimLab, but it's not working completely. And especially we hope to use this to export flux motor models directly into SimLab. The second thing is to support all the Flux entities. So there are still a lot of very complex things that are in Flux and not in SimLab, such as these complex formulas with the valid and the trapeze function and things like that. And a few very advanced materials also are not there yet. And finally, in the future, we also want to provide a seamless solution so that you can basically open an old Flux project directly in SimLab without the need to open it and export it and reopen it in SimLab, let's say. So that will come in a way we don't know exactly yet, but that will be one of the goals in the future for this solution. So thank you for your time. This was the Flux export to SimLab.